So my name is Ayush Joshi. I did my masters from IIT. I teach. So my name is Ayush Joshi. I did my masters from IIT. I teach JAM and CSIR students at GATE IIT Institute in Bangalore. Okay, today I'm going to teach a topic on CSIR net, and the topic name is Taylor expansion. Alright, the topic is Taylor expansion of a function. Taylor expansion of a function. The Taylor expansion of a function is writing any function in infinite series of polynomials. Okay, if I want to write any complicated function in infinite series of polynomial, what I will do Taylor expansion of that function. How to do Taylor expansion of a function? Suppose I have a function f of x and I want to expand. We want to find the value of function at some point, let's say random point x naught. So we have function f of x and I want to find the value of that function at some point x naught. How will we do the Taylor expansion of that function? We will write f of x. Then the first term will be the value of the function at that point x naught plus x minus x naught upon 1 factorial, and the derivative of the function df by dx at x equals to x naught plus x minus x naught square upon 2 factorial, the double derivative of the function d2f upon dx2 at x equals to x naught, and this derivative, triple derivative x minus x naught cube upon 3 factorial d3f upon dx3 at x equals to x naught, and this keeps on going forever. Okay, so you write the value of the function at that point, then the 1 factorial, and 2 factorial, and 3 factorial, and this gives you the closest approximation of how the function behaves around this point x naught. Alright, you want to check the behavior of that point around x naught. Okay, so you have to do the Taylor expansion. Okay, you can do this for complex also. You can replace x by z, and then the function becomes f of z naught plus replace everything by x naught to z naught. Okay, so then it becomes the complex df by dz at z equals to z naught, and then same thing. Okay, goes for this. The one important point we should mention is that we have to take the derivative of the function. If the derivative of the function is not defined, then the double derivative is also not defined, triple derivative is also not defined, the fourth order derivative is also not defining. Okay, so the important point is f of x and its derivative must be defined. Must be defined at z equals to z. If the value is not defined at z equals to z naught, then you cannot do the Taylor expansion of the function. Alright, let's take an example. F of z is equals to e raised to power z. Okay, and we can expand it about any point, but the most common point is z equals to 0. So let's expand this about z equals to 0. So we have e to the power z is equals to the value of the function at 0, e to the power 0 plus 1 by 1 factorial z minus 0, z minus z naught, and then the derivative of d by dz of e to the power z at z equals to 0 plus 1 by 2 factorial z minus z naught square d2 by dz2 of e to the power z at z equals to z naught, and this keeps on going forever. The simplest part is the derivative of e to the power z is always e to the power z. So I will get e to the power z equals to 1 plus z, that z square by 2 factorial, and then the series will be z cube by 3 factorial plus z to the power 4 by 4 factorial, and so on. Okay, another example is f of z is equals to cos z. Okay, and let's say about z equals to 0. Okay, so I am finding the derivative first, so that's easy. df by dz will be sin z with a minus sign, and d2f upon dz2 will be minus cos z. Alright, and d3f, the third derivative will be dz3 equals to cos z is again sin, right? Okay, so at z equals to 0, z equals to 0, this is 0, this is minus 1, and this is 0. So I will have the second term, and then I will have the fourth term, and so on and so forth. Okay, so if I want to write the Taylor expansion of this guy, cos z, I will write the first term, cos 0, that is 1, minus x square, or z square, by 2 factorial, plus z to the power 4 by 4 factorial, and keeps on going. Similarly, sin z will be z minus z cube by 3 factorial, plus z to the power 5 by 5 factorial, and so on. Because sin is an odd function, only odd power comes. Cos is an even function, only even power comes. One more detail I want to add here is called as binomial expansion. Binomial expansion, which is helpful in Taylor expansion. Okay, when the function itself is tough, then we have to figure out binomial expansion. So we have 1 plus x to the power n. This is the binomial expansion. Then we get 1 plus nx plus n times n minus 1 by 2 factorial and x square plus n times n minus 1 n minus 2 upon 3 factorial x cube, and so on. This is called as binomial expansion. And the important thing is when I put n equals to minus 1, because this is mostly used in mathematics and physics, 1 plus x to the power minus 1 will give you 1 plus minus 1 into x plus minus 1 into minus 1 minus 1 upon 2 factorial x square, and so on. So you will get 1 plus x to the power minus 1 equals to 1 minus x, and this will be minus 1 into minus 1 is minus 2, and minus 2 x square minus x cube, and so on. Okay, so this binomial expansion is very, very important. 1 plus x to the power minus 1, 1 minus x plus x square minus x cube, and plus x to the power 4, and so on. Alternate power of minus plus minus plus minus plus. Let's do a numerical. That was asked in that exam. The question was f of z was given as 1 upon z plus 1 and z plus 3. Okay, and you have to find the coefficient of z minus z naught square, where z naught is equals to 1. Okay, so we have to expand this function and find the coefficient of z minus 1 square. Alright. Now remember that when we do Taylor expansion, we write the first term f of z naught plus z minus z naught upon 1 factorial df by dz at z equals to z naught plus z minus z naught square upon 2 factorial d2f upon dz2 at z equals to z naught. So I have to find this. This is the coefficient. So I have to take double derivative of this guy and then put z equals to 1 on this to find the answer of this. Alright, and this is a complicated task. Complicated. Alright, so we avoid doing this. Okay. So we totally avoid doing this. What we do instead is that we know that we have to find at z equals to 1. Okay, so we need power of z minus 1. Okay, so I will put w equals to z minus 1 directly. Okay, and then z equals to 1 plus w and put it back here. When I put that back, I will get f of z is equals to 1 upon w plus 2 and w plus 4. The next step will be taking 2 common and 4 common, because w is in the range of z minus 1. So I will take 1 upon 2 common from here. I will get 1 plus w by 2, and 4 common from here, 1 plus w by 4. Like this. Alright, so this becomes 1 by 8, 1 plus w by 2, and 1 plus w by 4. So 1 by 8, and then I have 1 plus w by 2 to the power minus 1, and 1 plus w by 4 to the power minus 1. Like this. Okay, and now we have binomial expansion of this. Okay, so you don't have to do differentiation all the time. If you know binomial expansion, then the problem becomes easy. 1 minus w by 2 plus w square by 4. Don't open much more than square, because you have to find coefficient of square term. And this will become 1 minus w by 4 plus w square by 16. Like this. Okay, and search for w square terms, because w is z minus 1, so w square is z minus 1 whole square. So I have to search term for w square. So f of z is equals to 1 by 8 The first w square term will be coming from here. W by 2 into w by 4. So it will be w square by 8. The second w square term will be coming from here, plus w square by 16. And the third w square term will be coming from here, w square by 4. Okay. If we take the LCM, we will have 1 by 8 and the LCM will be 16. So it will be 2w square plus w square plus 4w square. So 16 into 8 is 128 and we have a 7. So this will become 7 by 120 into w square, or 7 by 128 z minus 1 whole square. So this is the coefficient of z minus 1 whole square. Without even differentiating, we have found this easily. If you differentiate, it will take a lot amount of time. Without even differentiation, we have found this by just opening the magnitude. Alright, CSIR and JAM exam is all about learning concepts and building concepts. Alright, but we have to figure out that we have to solve many questions in 3 hours. Alright, in 3 hours we have to solve 60 question or 75 question in 60 question in JAM and 75 question in net exam. Okay, so we need tips and tricks to solving these questions. Alright, we cannot solve all the questions by long methods. Like we cannot differentiate like in the last problem. Okay, so in order to learn this, okay, you need if you want to learn more about this, you can join KIT and learn from here about all the tips and tricks regarding this CSIR and JAM.